Hello everyone, I'm Katie Contos and welcome to today's webinar, which is hosted by the Clean Energy Solutions Center in partnership with the United Nations Foundation Energy Access Practitioner Network. Today's webinar is focused on the energy efficiency for energy access, latest trends and innovations. Before we begin, I'll quickly go over some of the webinar features. For audio, you have two options. You may either listen through your computer or over the telephone. If you choose to listen through your computer, please select the mic and speakers option in the audio pane. Doing so will eliminate the possibility of feedback and echo. If you choose to dial in by phone, please select the telephone option, and a box on the right side will display the telephone number and audio pin you should use to dial in. If anyone's having any technical difficulties with the webinar, you may contact the GoToWebinars help desk at 888-259-3826 for assistance. If you'd like to ask a question, we ask that you use the questions pane where you may type it in. The audio recordings and presentations will be posted to the Solutions Center training page within a few days of the broadcast. It will be added to the Solutions Center YouTube channel where you'll find other informative webinars as well as video interviews with thought leaders on clean energy policy topics. Finally, one important note to mention before we begin our presentation is that the Clean Energy Solutions Center does not endorse or recommend specific products or services. Information provided in this webinar is featured in the Solutions Center Resource Library as one of many best practice resources reviewed and selected by technical experts. Today's webinar agenda is centered around the presentations from our guest panelists, Sam Grant and Maya Gach, who have joined us to discuss the latest trends and innovations in appliance efficiency and their role in increasing access to clean, reliable, and low-cost energy. Before we jump into the presentations, I'll provide a quick overview of the Clean Energy Solutions Center, and Jem Porcaro from the United Nations Foundation will provide a quick overview of the Energy Access Practitioner Network. Then following the panelist presentation, we'll have a question and answer session where the panelists will address questions submitted by the audience. At the end of the webinar, you'll be automatically prompted to fill out a brief survey as well, so thank you in advance for taking a moment to respond. The Solutions Center was launched in 2011 under the Clean Energy Ministerial. The Clean Energy Ministerial is a high-level global forum to promote policies and programs that advance clean energy technology, to share lessons learned and best practices, and to encourage the transition to a global clean energy economy. 24 countries in the European Commission are members, contributing 90% of clean energy investment and responsibility for 75% of global greenhouse gas emissions. This webinar is provided by the Clean Energy Solutions Center, which focuses on helping the government policymakers design and adopt policies and programs that support the deployment of clean energy technologies. This is accomplished through the support in crafting and implementing policies relating to energy access, no-cost expert policy assistance, and peer-to-peer learning and training tools such as this webinar. The Clean Energy Solutions Center is co-sponsored by the governments of Australia, Sweden, and the United States with in-kind support of the governments of Chile. The Solutions Center provides several clean energy policy programs and services, including a team of over 60 experts that can provide remote and in-person technical assistance to government and government-supported institutions, no-cost virtual webinar training on a variety of clean energy policy topics, partnership building with development agencies and regional and global organizations to deliver support, and an online library containing over 5,500 clean energy policy-related publications, tools, and videos, and other resources. Our primary audience is made up of energy policymakers, analysts from the governments and technical organizations in all countries, but we also strive to engage with private sectors, NGOs, and civil society. The Solutions Center is an international initiative that works with more than 35 international partners across its suite of different programs. Several of the partners are listed above, include research organizations like IRENA and IEA, and programs like SC for All, and regional focus entities such as EcoWatts, the Center for Renewable Energy and Energy Efficiency. A marquee feature that the Solutions Center provides is a no-cost expert policy assistance known as Ask an Expert. The Ask an Expert service matches policymakers with more than 60 global experts such as authoritative leaders on specific clean energy finance and policy topics. For example, in the area of appliances and equipment, we are very pleased to have Christine Egan, Executive Director of CLASP, serving as one of our experts. If you have a need for policy assistance in appliances and equipment or any other clean energy sector, we encourage you to use this valuable service. Again, this assistance is provided free of charge. If you have a question for our experts, please submit it through our simple online form at cleanenergysolutions.org/expert. We also invite you to spread the word about this service to those in your networks and organizations. Today's webinar is co-moderated by Jem Porcaro, who's the Senior Director for Energy Access at United Nations Foundation. Now I'd like to provide brief introductions for today's panelists. First up is Sam Grant. He joined CLASP as the Africa Regional Lead last April with 10 years experience working in energy access. He lived and worked in Papua New Guinea, Mongolia, Ethiopia, Uganda, and Kenya. Sam previously held leadership roles at the Equality Group Foundation in microenergy credits. And our final speaker today is Maya Gaich, who has just been awarded her PhD in engineering on the topic of designing hybrid solar collector. She will be soon traveling to Liberia to work on the Light Up Liberia project, working for Porcaro as a project manager. And with those brief introductions, I'd like to welcome Jem to the webinar.
Thanks, Katie. I'm going to just try to show my slides. I just have a few. Can you see my slides?
Yes, they look great.
Great. Thanks, Katie. And thanks to everyone for participating today, especially Sam and Maya. Really looking forward to this webinar on energy efficiency for energy access. I hope most of you are familiar with the Practitioner Network, but if not, the network is an initiative of the UN Foundation that was established roughly 7 years ago as our contribution to sustainable energy for all. Our overarching aim is really to support the development of market-led, decentralized energy access solutions and businesses. And so in many ways, we are kind of a field, the network is a field building initiative. We kind of carry out our mission by helping unify the sector, by accelerating learning amongst stakeholders within the sector, and by trying to elevate the distributed energy access sector within international development agenda. And we have a number of tools that are for doing that. Amongst them are creating market intelligence through surveys and contributing to other research, convening the sector, sharing knowledge through webinars like this one, communicating news through newsletters, our website, and through promoting the sector. We started out with about 20 members in our network about 7 years ago. We have now about 2,500, representing roughly 1,400 organizations working in almost 200 countries around the world. The network is predominantly comprised of SMEs and NGOs and corporations, but we also have a good mix of development partners, CSOs, academia, government, and investors. So today's webinar is more specifically focused on looking at the latest trends and innovations in appliance efficiency and their role in increasing access to modern energy services. And for that, I'm really excited and lucky to have Sam and Maya with us. This is the fourth webinar in a series of webinars looking at kind of best practices more broadly. And as usual, you can always follow us on social media. So before I pass things off to Sam, let me just tee things up by saying how important we think energy efficiency and super efficient appliances are to expanding energy access, especially to higher tiers of access. I think, as we all know, the global market for clean energy technologies, including solar lanterns and solar home systems, have grown significantly over the past few years. But it's important not to forget that these markets have largely provided basic levels of energy access, typically power to charge a phone, power to charge a mobile phone, maybe a few lights. And while the growth of this market is a huge achievement in itself and kind of is a critical first step to get on the energy access ladder, achieving greater socioeconomic benefits really will require the provision of higher levels of energy services to off-grid consumers. And this is where off-grid appliances are really important, as appliances are really what help bridge or convert energy supply into energy services. After all, no one really cares about electrons themselves. They really care about the energy services like lighting, entertainment, information, communication. However, a major challenge in delivering these higher levels of access is the fact that traditionally, traditional appliances and end-use technologies consume too much power to be cost-effectively bundled or supported by available off-grid energy technologies. The good news is, which hopefully we're going to hear quite a bit about from Sam and Maya, is that there's a kind of a new class of energy efficient appliances coming online that are becoming more available to off-grid, more available in off-grid applications. So that's really the crux of this webinar, to kind of dive into what are those new class of technologies, what are some of the latest innovations and trends to look out for. And so, sorry, I meant to press my button there. With that, I think I'm going to hand it over to Sam to take it over. Sam, all yours.
Thanks, Jim. Thanks for that introduction. Hello, everyone. I've got a lot of slides, a lot of information, and so I'm just gonna jump into it. If you could, and Katie's going to be assisting me with moving the slides. Thanks, Katie. So, yeah, off-grid appliances, as Jim mentioned, are kind of a critical link between energy supply and energy. No one wants electrons; they want light, refrigeration, entertainment, water pumping. A good off-grid or weak-grid appliance is designed with consumers in mind and is suitable for use with a solar home system or a mini grid. And it's designed, with really thinking, not just about energy efficiency, but also quality and reliability. It's so important for energy efficient appliances to be, affordable, easy to operate, and easy to maintain. Many times these different attributes are trade-offs, and we'll jump into some of those trade-offs a little bit more for specific appliances later on in the presentation. So energy services are evolving for the off-grid sector. Next slide, please. And there's growing demand. This is from a 2016 global market research study that found that under-electrified households currently spend over $100 million on fans. Many of these products are not efficient or appropriate. And I think collectively, much better than much higher quality appliances. Affecting off-grid is always closer to $4 billion by 2020. But achieving well-designed products will require innovation, market development, and significant scale-up by new and existing suppliers. Next slide, please. So, energy efficient appliances are important. They reduce the overall cost of the total system. Here in this slide, we see a 2015 analysis from Humboldt State and Berkeley National Laboratory. This study found that the upfront cost of a typical off-grid energy system can be reduced by as much as 50%. Super efficient appliance like solar PV and batteries are used, while delivering equivalent or even greater energy services. Efficient appliances can rapidly reduce the cost of solar and PV, fundamentally changing both the life cycle cost and the prices consumer space. With the savings from avoided energy supply and energy more than make up for the additional. Efficiency and design are just as important in weak grid systems where supply is constrained and consumers have the same expectation for quality and appropriate design. Many of the people that I speak with here in Nairobi, who are on a prepaid meter, for instance, they have a very tight budget for how much they spend and put on that meter each month. And they know exactly how many times they can iron their kids' clothes or turn on the water kettle. So energy efficiency is really important for both sectors. Next slide, please. So that previous slide was a little bit older information, and many of you know that the decrease in system costs has been driven largely by a reduction in PV prices and even more recently in battery storage prices. So here's some more recent information. You see that the market is moving quickly and baseline performance is improving, which is encouraging. So we refreshed kind of the previous slide's analysis with just two years later and found that in 2016 a small solar home system appliance package using conventional appliances as opposed to a solar home system that was using kind of the most super efficient appliances that we've tested and found on the market, we found about a 20% cost reduction or benefit. So 20% is significant, but we think that there's a lot more work to be done, and we think that the opportunity is even greater with additional appliance efficiency improvements. Next slide, please. So over the past few years, a variety of off-grid market stakeholders would occasionally ask us at CLASP if we thought refrigeration could ever be viable for small-scale or off-grid energy systems. And I think, based on the previous slides and your knowledge of the market, you can agree that not only is off-grid refrigeration, potentially viable, but it could potentially play a crucial role in the future of the off-grid market if we build refrigeration to match the system sizing that can be, feasibly afforded by the majority of off-grid customers. So in order to understand kind of the potential impact of a refrigerator on an off-grid energy system size, in the slide we've added a refrigerator to the set of appliances that we used for the modeling earlier. The green icons show the amount of PV and battery capacity needed to run an off-grid appropriate refrigerator as part of a load that also includes 4 LED lights, radio, phone charger, a fan, and a TV. The orange icons show the amount of PV and battery capacity needed to run an average conventional on-grid refrigerator product with the same load and the same bundle of other appliances. So the results are pretty stunning, as you can see pretty clearly. The off-grid appropriate refrigerator can be run with an 80-watt peak PV array and a 35 amp-hour battery, both of which are well within the range of many of the leading solar home system companies and the systems that are commonly available on the market today. However, you would need almost 9 times the amount of PV and battery and almost 8 times the amount of battery capacity if you were to use kind of conventional refrigerator that's sold for the on-grid market. So the cost of the system, system size would be a non-starter for most off-grid customers if they were to use a conventional refrigerator. It just would never be possible, and that's one of the primary reasons why in the Kenyan market, less than 1% of rural households own a refrigerator. It's just not within their reach. Next slide, please. So there are many barriers inhibiting kind of the scale up and development of appropriately designed off-grid appliances in the off-grid appliance market. product design and development. Many off-grid solar companies struggle to identify or develop great appliances, and appliance manufacturers are typically unaware of the off-grid market design needs. They're largely two separate communities that don't communicate with each other. So there's really a large information gap there. Many of the appliance manufacturers are just not aware of the off-grid market opportunity. They don't see a potential $4 billion market. They don't see anything at all. And those that are aware kind of struggle to find a clear path to the market, and see just too many risks to take the time and effort that would be required to really move into it aggressively. Many of the off-grid solar companies, they often lack financing to expand their appliance product offerings or switch to different appliance vendors. There's definitely a searching and transaction cost associated with going to OEMs in China and engaging with manufacturers and testing those appliances in the market with their systems. And then all of those costs really led to, I guess, a very timid introduction of appliances so far by solar home system companies. Next slide, please. So, as briefly mentioned before, there's kind of a sweet spot of value for an off-grid appropriately designed appliance. We tend to evaluate off-grid appliances with 4 key criteria: energy consumption or energy efficiency, price, size, and service delivery. Efficiency alone doesn't make an appliance off-grid appropriate, price doesn't either. There's typically trade-offs within these 4 parameters, and we work with a lot of manufacturers to try to find the best balance between the 4. Next slide, please. So one way in which we've tried, CLASP has tried to enable the market to better understand the off-grid appliance landscape is doing product testing. So this is all done under the Global Leap Awards. So the product testing component of the Global Leaps is based on test methods and consultation with leading international technical and market experts. Typically, the test methods are based on the International Electrotechnical Commission's standards, and then we add additional tests to address performance requirements and environments that are typically found in off-grid households. And so these battery of tests are done in laboratories in the Netherlands, India, and China. To date, we've developed off-grid appliance test methods for fans, televisions, and refrigerators. And this really this acts as the core, the foundation of most of the work that we do in the off-grid space. Next slide, please. So with all of this testing, we've developed an off-grid appliance data platform, which provides easy access to appliance test and market data. Hopefully, systemically attacks kind of that gap in market intelligence for both solar home system companies or people that would wish to procure off-grid appliances and manufacturers and designers. So we procure and test, we share the data with anyone who asks us, and we hope that this helps the market make smart appliance choices. We currently are building out a web platform for this database that we hope to launch later in the year. At the moment, all of our testing data resides on a giant Excel sheet. which I'm happy to share with anyone interested in participating on this call. Next slide. So here's some of the testing results from fans. So, it's crucial to keep in mind that there's a significant difference out there in the market with respect to any given off-grid appliance in terms of energy efficiency. This is data from our off-grid fan testing efforts. Shows a significant spread in terms of how much airflow a given fan delivers per watt between the highest performing products and even the average in the market. These differences have a huge impact on the energy and the energy costs required to deliver the service that an off-grid family or business expects and deserves, really. But if you don't have that information, if you're not testing for these very real kind of performance and energy efficiency differences, or otherwise accounting for them somehow, you're not equipped to make a decision. To me, the air delivery differential and energy consumption difference in fans is personally one of the most striking data points that shows the vast discrepancy in the market. Next slide, please. So when we evaluate or look at kind of the drivers to increase efficiency in the off-grid fan space, we look at a few key technologies. So one of the obvious standout ones is brushless DC motors are lighter, they're more durable, longer lived, and notably more efficient than traditional brushed motors. Given their low economies of scale, though, they're currently usually way more expensive, and really increase the fan's retail price. But they're super efficient, and their longer life can dramatically improve kind of the lifetime costs of owning and operating a fan, especially when you're using expensive energy. Motion and occupancy sensors. This is something that we've experimented with quite a bit in the Bangladeshi and Indian markets. Fans typically are just left running, and then they burn through any battery charge built up from the solar panel. So just building in different features that really optimize the life of a battery charge can be really important in an off-grid context. Next slide, please. So what you see here on this slide is data from our TV testing efforts. And again, I won't harp on, but you see significant differences in the energy efficiency that's currently out there on the market. And that energy efficiency makes a big difference in the system sizing. Next slide. And again, there are a lot of ways to make an off-grid TV more efficient. I've done a lot of research in that, and to do it cost effectively, most importantly. One of the most innovative things that we saw in the early days of this market was an off-grid appliance specialist responding to the stresses in terms of energy consumption that loudspeakers place on off-grid energy supplies. So rather than using traditional TV speakers, they started using an array of iPhone speakers. The decibel level was just as loud. The sound was very good, but the energy consumption was a fraction of what those other more traditional TV speakers were consuming. One of my favorite anecdotes about TVs is a chat that I had with an executive at a prominent desco. We were talking about off-grid TVs, and he told me, we're always working with suppliers on efficiency of their products. There are cheap, easy things manufacturers can do to make appliances more energy efficient. But when I ask them why they haven't done so already, they say nobody's ever asked them to. So the Samsungs, the LGs of the world, in many ways, they're just not they're not building to this particular market. It's just not an important market segment for them. So one of the things that we're trying to do is to really, tease out what features would be required by those larger multinational conglomerates to make a really affordable, efficient TV. We're not there yet. Still working on that. There's a lot of work to be done, but we think it's important to do. Next slide, please. So this slide compares the energy performance of the off-grid refrigerators tested as part of the global LEIA market baseline testing efforts, and the rated energy performance of the products nominated for our most recent global LEIA awards for off-grid refrigerators. And you can see energy performance for products nominated in the global LEIA award competition is generally much better than the sampling that we've been able to do out in the market. I know that the graph shows watts per liter, so that's a metric that allows us to control for product size when looking at energy performance in refrigerators. And the energy consumption metric displayed in the spider graph earlier was more of a kilowatt hours per day and has a rough correlation with product size. As larger products tend to require more energy in aggregate, as you would assume. However, you can see here the relative energy efficiency of the refrigerator product actually tends to increase along with the product size. As there's a minimum threshold energy required to start a refrigerator, really of any size, based on the energy consumption of powering up the compressor. Kind of the main takeaway here is that there are widely divergent levels of energy consumption, even in products of similar sizes. As you can see, the 23-liter product was called out here runs on just a little more than a third of the energy compared to the 25-liter product. So that's a huge difference. Next slide, please. So refrigerators are interesting. We've very recently been really trying to dig deep into advanced refrigeration technology and really understand, what kind of what progress can be made to make refrigerators more affordable and decrease that percentage, from 1% of rural Kenyan households to a much higher number in the near future. So what parts of a refrigerator drive energy consumption? And what are some of the levers that can move a refrigerator from an inefficient 25-liter product to a highly efficient 23-liter product that we saw on the previous slide? So the largest single driver of refrigerator energy performance is the compressor, which is the component that enables the actual cooling of air inside the chamber. And compressor efficiency has improved pretty significantly in mature on-grid markets in the recent past, resulting in roughly a 10 to 15% improvement in overall refrigerator efficiency over the course of the last 5 years. While we're starting to see some of these advancements cascade into the off-grid refrigerator product market, the most immediate opportunity to increase off-grid refrigerator efficiency really continues to be increased adoption of these more efficient compressor designs. Further innovations in compressor technology, such as variable speed compressors that enable the unit to consume greater or lesser amounts of electricity depending on the actual temperature of the internal chamber, and whether it needs to be lowered by, say, 2 degrees or 5 degrees. This type of compressor could radically reduce the amount of energy consumption by our calculations by as much as 30 to 40%. And then more obviously, cabinet insulation, is an important determinant of refrigerator energy consumption. Most products developed for on-grid markets have about 1.5 inches of polyurethane foam insulation. But if that's increased to 4 or 4.5 inches, refrigerator efficiency can improve by as much as 30%. Advanced insulation technologies could further drive improvements, but many of those types of materials are just too far away from being commercially viable or in a price range that off-grid customers could afford. And I guess one more kind of anecdote. I was at a CLASP colleague's house in Washington, D.C. A month ago, and his refrigerator in his home has a water dispenser built into the refrigerator, but it's actually inside the refrigerator. So you have to open up the door and leave it open as you're filling up a glass of water, or a pitcher of water. And to me, that was a laughable example of how the on-grid refrigerator appliance market is not thinking about the off-grid sector when they're designing these appliances. Next slide, please. So I'm just going to quickly now run through just a few of the programs that CLASP is working on to try to drive greater energy efficiency and energy access in the off-grid market. So the Global Leap Awards, as I mentioned previously, identify and promote the world's best off-grid appliances, evaluating them on the basis of quality, off-grid appropriateness, energy efficiency, and cost. Looking at a lot of the product performance characteristics that we just reviewed. The awards signal the importance of product performance and quality to the global market, and this helps off-grid energy companies kind of jumpstart their search for high-quality appliances. Hopefully, it gives appliance companies a clear point of entry into the off-grid market. We include the winners and finalists in the off-grid appliance data platform that I mentioned before, and we circulate an annual buyer's guide, which we hope is being used by manufacturers and off-grid solar system providers to inform purchasing decisions. Next slide, please. We've recently launched the Efficiency for Access Coalition, which kind of brings together some of the tools that we're creating for the very first time, specifically to advance the deployment of high quality, appropriate, energy efficient, and affordable appliances. Next slide. And kind of the low energy inclusive appliance program is the latest and most substantial to date contribution to that coalition. LEIA's ambitious goal is to double the efficiency and halve the cost of a range of appliances and technologies over the next 5 years. We've broken out those appliances and technologies into kind of near to market products such as TVs, fans, and refrigerators, solar water pumps, and we're going to really focus on kind of scaling those markets. And then we'll take a look at more kind of horizon and enabling technologies such as brushless DC motors and electric cooking, and hopefully stimulate those sectors with R&D investment. Next slide, please. We've recently launched an off-grid cold chain challenge where we're looking at off-grid cold storage containers. And this is a pretty nascent market, very developed on the on-grid side of things, but very few actors in the off-grid space. And so we're hoping to bridge technology gaps and kind of reward promising business models in this space. And then next slide, please. Finally, we've recently took over management of the Lighting Global Quality Assurance program housed within the World Bank Group. And eventually, the same type of quality assurance that the Lighting Global program is applied to Pico solar products and plug-and-play solar home system kits. Eventually, we hope to apply the same letter of kind of testing and quality assurance to off-grid appliances, fans, TVs, and refrigerators. For the development and refinement of the testing methodologies that I mentioned earlier, they're the beginning of this process. And that is a lot of talking from my end. That's it from me. Thanks so much, everyone, for listening.
Thanks, Sam. Thanks very much. It's really impressive how much CLASP is contributing to the off-grid appliance market. I think in the interest of time, we're going to quickly segue to Maya now to give a slightly different perspective, a perspective from a practitioner and Porcaro, who has been doing a lot of great work providing off-grid appliances. So Maya, the floor is yours.
Thanks for the introduction. Thanks for the interesting presentation, Sam, and thanks everyone for listening. So my presentation will be quite a bit shorter, so I think we'll be able to stick with the time. So just trying to switch my slides over. So Porcaro is a German-based manufacturer of solar home systems that come with solar panels from 1.5 watts to 50 watts for our largest systems. But soon we'll be introducing an even larger product, which I'll mention a bit later. Porcaro's headquarters are in Germany, and our main manufacturing plant is in Thailand. We also have assembly lines in Ethiopia and Kenya, and hopefully soon in Liberia. Apart from solar home systems, we also manufacture high-efficiency LED lamps, as well as accessories and efficient DC appliances such as fans, televisions, radios, torches, and lanterns. And Porcaro's vision is to enable people all around the world to have access to the same energy services that we do. And so for people living off-grid, this means that they need to have access to appliances that are low-cost, efficient, and easily available. So DC appliances have conventionally been used by a limited number of niche off-grid applications, resulting in quite a low demand and an immature market not quite reaching economies of scale, as mentioned by Sam. However, according to the Gogla Off-Grid Solar Market Trends 2018 report, since 2010 there have been approximately 130 million solar off-grid devices sold, an impressive growth that's expected to continue. And so there's a huge potential in this market for DC appliances as we start to see millions of households around the world gaining access to modern energy services and starting to move up the energy ladder. And this occurs as consumers naturally start to seek out more complex energy services after their basic lighting needs have been met. So Porcaro offers DC plug-and-play solar home systems that are safe and can be easily installed by anyone. And to offer customers low-cost energy services along with the solar home systems, we have been focusing efforts on designing highly efficient and smart appliances. And so, for example, our award-winning 12-volt DC TV consumes only 6.5 watts for the 11-inch screen size and only 12 watts for the 24-inch size. And so here the trend can be described as redesigning DC appliances to have both high efficiency and a low cost. So another example of an appliance we have developed is our new fridge. It's called the CoolSun 60. It has a maximum power draw of 45 watts and 54-litre capacity. And to keep costs low and minimize reliance on expensive batteries, thermal storage in the form of a phase change material has been incorporated into the fridge. And using the latent heat stored in the phase change material, we reduce compressor runtime. So the material freezes at 6 degrees Celsius during the day using solar energy, and then in the night, any heat absorbed melts the phase change material slowly while maintaining constant temperature in the fridge. So we are focusing on maximizing use of energy during sunlight hours to avoid having to increase battery size, which is the most expensive part of the solar home system. And the fridge has two modes, a smart mode, so when combined with a Porcaro system, maximizes the benefits of the phase change material, and then also a manual mode that can be used with any system for constant cooling to between 2 and 8 degrees Celsius. Another example of an innovative solution from one of our partners is a hot water system based on a Peltier semiconducting element. And so in this case, there's no need for plumbing coming from the roof for the solar hot water, just electricity. And solar power is used to heat the Peltier element during the day, and the well-insulated tank keeps the heat in at night. And in this way, by keeping the balance of system costs down, the overall cost is kept quite low. And so with these two examples, we see a trend of using novel energy storage methods to keep costs low by reducing the amount of energy required from a battery. And then these types of appliances can be made more accessible. So fridges, hot water systems, and TVs will always need more energy than just basic lighting. And to power these types of appliances, Porcaro is soon releasing a new product range called Evo, which will have panel sizes up to a couple of 100 watts. And the Evo range is innovative as it will consist of a hybrid lithium-ion and lead-acid battery. So the lithium-ion will be the primarily used battery, and lead-acid will act as an energy backup. And the system, coupled with Porcaro's appliances, will be able to intelligently manage day-to-day power consumption. And then with this system, users will have the option to grow and extend the system in several steps, providing a power supply similar to Western households, but with lower risks of debt default. And so looking to the future, it will become increasingly important to focus on integrating productive use appliances with solar home systems, such as sewing machines and solar water pumps. And obviously these need to be redesigned to be able to be powered efficiently by solar power. And finally, the problem of figuring out how to cook efficiently with solar power still needs to be solved. So that's all from me. Thanks for your attention. If you have any questions, you can email us at this address. Thank you.
Thanks, Maya. That's really great. So I'm going to take moderator privileges and maybe just ask a couple of questions of Maya and Sam, really just as a way to kickstart a longer Q&A session that I think Katie will manage with those who are online. So let me just jump into it. I think we heard both from Sam and Maya kind of the importance of stimulating supply amongst appliance manufacturers to develop more super efficient products. I was hoping you could both, or perhaps Sam, say a little bit more about that. What sort of incentives, what do we need to be doing more of to stimulate, to get more appliance manufacturers to develop and pay attention to these markets? Is it more data about what the market looks like, size, the demand? Is it more about a better understanding of the characteristics of the actual appliances that need to be developed? I'm just hoping you could say a little bit more about that, just given how important it is for achieving economies of scale. So I don't know if Sam or Maya, if either of you want to take a stab at that.
Yeah, I mean, I think that's a good question, and I don't think we definitely don't have an answer to it. We've run consecutive Global LEAP Awards since 2014, and we have every year we see more and more interest, more partnerships from larger multinationals with solar home system companies and product designers. And I think there's a certain amount of risk in entering the market first that a lot of the large players are just unwilling to do. And so I think proving out market demand is really important. The last round of Global LEAP Awards for TVs and fans in 2017 was accompanied by a results-based financing program where we subsidized the bulk procurement of Global LEAP winners and finalists. When we opened up that RVF window in October, we sold committed 270,000 TVs and fans across Africa and Bangladesh within a 72-hour period. And we were blown away by the interest and the demand for these products that RVF round generated, and we're very, very pleased. we're running a similar RBF program for refrigerators, but we're seeing a much just slower uptake. There's a lot more caution in the market. But we're hoping that those kind of incentives to kind of lower that first mover disadvantage in many ways. We hope that that will prove out the market and encourage in the future more companies, larger companies, to participate in this space.
Right. Maya, did you want to add anything to that?
I guess I just want to say the market is still really immature and it will take off. And I think once it takes off, then everyone else will start to jump on board. So I think it's just a matter of time.
Yeah. And Maya, maybe this is a question for you. I mean, your TV, has got a lot of attention and awards over the years. I was wondering, could you say a little bit more about your product offering and where do you see the biggest demand moving forward? As I understand it, TVs are kind of are large, represent a large portion of demand for off-grid appliances. What's driving that demand? I'm curious, kind of what exactly your customers value and how do they use these? Or are there other products, other appliances that you see promising growth for in the years to come?
Well, I've just recently joined Porcaro about a month ago, so I don't have lots of in-depth information, but from my understanding, the TV is really one of our most popular appliances, and I think mostly it goes to East Africa and a lot of other markets too. But we're really excited about the fridge. I think we see a huge potential and a lot of interest in the fridge. So yeah, I think that's where it's heading.
And I mean, speaking of the fridge, is that now available on the market?
Yeah, that's right. Yep, it's available now. We've been working on that. Our R&D team has been working on that for a while now, and it is available.
And just so people get a sense, if you're comfortable saying, what's the price point for that refrigerator?
X works, so without shipping, it'll be around $350 US.
Okay. And I recognize you're quite early on, but what's the sense of what part of the market do you see that demand coming from for the refrigerator, given that price point?
I guess this is something that once solar home systems have been paid off, it would be like the next steps. So you've paid off your system and it could be offered with pay-as-you-go. So on the Evo system, you can add a solar panel and add the fridge, and then you would have some time to pay that off. But that wouldn't be for the consumers just entering the market. This would be like to keep moving existing customers into getting more access to these services.
Yeah. Okay. Maybe one last question is a little bit of a kind of more technical question related to compatibility and interoperability. And maybe to you, Sam, or both of you, as I understand it, appliances, there's a little bit of compatibility across appliances as it relates to solar home system products with kind of proprietary plugs. And then kind of a related question around what happens inevitably when perhaps a mini grid arrives to communities that are using these DC appliances. Maybe Sam, can you say a little bit more about what's CLASP's kind of thinking around interoperability and compatibility issues? Are there efforts to move the sector from kind of these proprietary plugs to more universal plugs to stimulate more competition and compatibility? Curious if there are efforts around that.
Yeah, it's a great question, and obviously in the on-grid appliance sector, there's a lot of interoperability. You use the same plugs that plug into your wall, unless you go to another country. But you definitely don't see that in the solar home system space, and that's for a variety of very sound business reasons. And one of the enabling technologies that we'll be investigating under the LEIA program is exactly that, interoperability and compatibility, and kind of the issues and the opportunities surrounding that. I think just from kind of a personal anecdotal, I think it's going to be very challenging to get solar home system companies to move away from having unique plugs and cables, just because so much of their business model revolves around the financing of those appliances, and you need some kind of lockout mechanism to be embedded within the product. Possible that the section will move away from that, but I don't see a clear path forward to make that happen or to entice businesses to do that. Hopefully, that's something that we'll tease out over the next 5 years through some of the research and R&D that we'll be deploying through LEIA.
Right. Okay. Well, something to look forward to under LEIA. Okay. I think I've maxed out my moderator privileges, so I'll maybe kick it back to Katie to manage some Q&A amongst those who are online.
Wonderful. Thank you, Jem, for that interesting question and answer discussion. And thank you both Maya and Sam for the outstanding presentations. As we shift to the question and answer session, I just would like to remind our attendees to please submit questions using the question pane at any time. We also keep several links up on the screen throughout for quick reference that point to where you can find information about upcoming webinars and other previously held webinars, and also to take advantage of the Ask an Expert program. We've had some great questions from the audience. Our first question is for either Sam or Maya. Sam, Sam, I think this is directed, but please feel free to comment, Maya. How do consumers contribute data to the platform, and what data are you looking for?
Yeah, that's a great question, and this has come up a lot more in as we deploy those 270,000 off-grid TVs and fans through the Global Leap Awards. We have a contractual obligation to verify that those products have ended up in the household where they have been presumably sold, and in addition to verifying the sale, hopefully we'll collect some impact data. A lot of the pay-go companies capture information and know when those appliances are being used during the day, and that's really helpful information as far as designing systems to work in conjunction with those appliances. We recently held a solar water pumping technical roundtable where there was a lot of discussion around what type of data should be collected from these systems to inform customer service, to help restructure financing arrangements. No one really knows yet. There's a lot of experimentation that's going on across different solar home system companies and providers, and definitely an area that hopefully we will explore further. Obviously with data privacy kind of front and center of a lot of people in the United States lives. Facebook, there's also a lot of discussion on what are the ethical implications of monitoring these appliances with remote sensing and GSM technology. And that's something that the industry is going to have to get out in front of and kind of decide before regulation hits what's the ethical information to collect. And I don't think anyone has an answer to that yet.
Great, thank you, Sam. And to follow on that, what are the ways, the tools, the handheld measurements that consumers can use to figure out the energy that their individual appliances put out?
It's a great question. I mean, there's nothing like that I know of that's available to a household using a solar home system here in Kenya or in East Africa. A lot of the kind of, I guess, system indicators are usually in the form of just like light bars that are on the battery and charge controller base. Or if it's so that's usually where they'll get information on how much charge they have left. Some do it in kind of a bar label. Some have the actual hours till the light will run out, or the appliance will stop working. So those are the only tools that I know of so far. I believe some companies are looking into, as systems get larger and there are more appliances attached to the same system, companies are thinking through energy management at a household level through, potentially SMS messaging, thing like, letting people know, giving people some kind of indication that, you only have an hour left of TV. You might want to dim your lights if you want to watch the rest of that English Premier League game, because those are going to be important signals to consumers so that they can get the maximum benefit out of these kind of constrained power systems and appliances.
Thank you, Sam. Maya, and Sam, please feel free to comment as well. What is the level of risk associated for these new efficient appliances from the perspective of the consumer?
Well, I mean, I haven't been involved that long with developing these appliances, so I'm not sure how to answer that. But I mean, I guess there is a risk with any early adopters of technology. So I know the one case of, I'm not sure if you remember Aqueon batteries. There was a salt-based battery, a big plant built by Bill Gates Foundation, like really cool technology, got deployed, but then suddenly lithium ion came along and just the whole company went bankrupt. So there's always a risk being an early adopter of technology, and yeah, I guess that's all I can think to say.
Thank you, Maya. Our next question is from our consumer, and they want to know, as we shift out of these appliances and become with more energy efficiency appliances or batteries, what are the plans are, or what do you know of for the waste that's left over and for these old appliances?
That's also a really good question, and their CLASP has worked a lot on the on-grid appliance space to develop kind of end-of-life management plans, both at a kind of a policy governmental level and then also at an industry level. GOGLO, which is the Industry Association for Off-Grid Lighting, recently convened an e-waste end-of-life workshop here in Nairobi last Thursday, actually. There was a lot of really stimulating conversation around what companies should do, how they can get out in front of any potential, policy that will be put in place. Because there's a lot of concern with disposal of these systems, especially if they're dependent on lead acid batteries, because those find their way into water tables or buried in fields where crops are grown over those. So it's definitely something that needs to be thought through. It's challenging just given the geographic limitations of where these off-grid systems and appliances are being deployed. There's a negative value chain in reclaiming that product at the moment, right? And so it's going to take a very coordinated effort and probably some kind of public assistance to find a responsible way to get those products back at the end of their life cycle. We've seen at the workshop, we heard of companies who are reclaiming appliances and systems, breaking them down, repurposing them, using them for spare parts, building them into refurbished systems, and then selling them back on the market. Trying to find a way to switch that kind of negative value chain to a positive one. I don't think any of them are there yet, but it's definitely something that the industry as a whole has to get out in front of. There's a possibility, I think, or an opportunity to use kind of innovation prizes as a way to kind of tease out best practice, or to find a method or a process that works really well. So there's a possibility that we'll see innovation prizes deployed in the future to solve this critical piece of the off-grid appliance ecosystem.
Katie, if I may, I would just quickly compliment what Sam said. I think he's absolutely right, and I think Gogla is doing some good work in this space. I would also just direct people to our webinar in December of 2017 that actually covered this precise topic. So for those who want to dig in a little bit more, look up our webinar on our website for December. That's dedicated to recycling of off-grid solar products.
Great, thank you both, and thank you, Jem, for reminding us of that webinar. Our next question for Sam and Maya is, to the best of your knowledge, is there anything that is equivalent to these domestic appliances in the power tools or low energy commercial freezers and packaging machinery area?
There's very little. You might know of more appliances that fit into that category. I know that Mobisol has deployed a welder with their largest 350 watt system. There are several solar water pump companies that are very, very early stages of development, but are available on the market. There are a handful of solar powered milling machines that are commercially available, but also those companies are very small and just really getting off the ground. There's several freezers that have been developed, but there's a lot of room for improvement in freezing and ice production. And we plan to run another round of the Global Leap Awards for refrigeration, and we're hoping that one, Porcaro will enter their newly developed TV, but along with a lot of other companies, we've seen a lot more people kind of take stock of the opportunity for freezing, ice making, and refrigeration on a commercial basis in an off-grid setting. That's all that I'm aware of. So very limited, I guess, to sum up. It's definitely the focus. I would say it's the focus of a lot of donor and government efforts to focus on developing the market for productive use off-grid appliances and machinery. And it's really seen as the key to moving the whole sector forward.
All right, thank you, Sam. Thank you all for the informative question and answer session. Now I'd just like to provide each of you with an opportunity for any additional or closing remarks that you'd like to make before we close the webinar. Jem, why don't you start?
Yeah, no, and I just want to thank again Sam and Maya for spending the time with us today to talk about this issue. Obviously something that we are quite interested in and will continue working with CLASP on. For those of you who may not know this, we've been working with CLASP over the years on a survey that they conduct on off-grid appliances, and hope to continue to do that moving forward. So, but again, just a big thank you to Sam and Maya and to everybody for participating today.
Thank you so much, Jem. Sam, would you like to provide any closing remarks for today's webinar?
Oh gosh, I feel like I've probably talked too much. So I guess I would just leave with it. And energy efficiency is an often overlooked tool to increase energy access. And I think it deserves a lot more attention and focus from designers, manufacturers, donors, NGOs. There's a lot of low-hanging fruit there that has huge ramifications for both the on-grid appliance sector and the on-grid and off-grid appliance sectors. So I think hopefully we'll continue to see improvements made so that more people can watch TV and cool off with a fan and have a cold drink in the heat of the day.
Great. Thank you so much, Sam. Maya, would you like to close us out for the day?
Sure, yeah. I would also like to thank everyone for listening. Thanks, Jim, and also thanks to Katie for organizing such a great webinar.
Great, thank you both. On behalf of the Clean Energy Solutions Center, I'd like to extend a thank you to all of our expert panelists and to our attendees for participating in today's webinar. We very much appreciate your time and hope in return that there were some valuable insights that you can take back to your ministries, departments, or organizations. We'd also like to invite you to inform your colleagues and those in your networks about the Solutions Center resources and services, including no-cost policy support through our Ask an Expert service. I invite you to check the Solutions Center website if you'd like to view the slides and listen to the recording of today's presentation, as well as previously held webinars. Additionally, you'll find information on upcoming webinars and other training events. We are now also posting the webinar to the Clean Energy Solutions Center YouTube channel. Please allow about a week for this audio recording to be posted. Finally, I'd like to kindly ask you to take a moment to complete a short survey that will appear when we conclude the webinar. Please enjoy the rest of your day, and we hope to see you again at future Clean Energy Solutions Center events. This concludes our webinar.